Hi there, I'm Dr. J, and in this video we're going to dive into the world of AI-powered compliance tools, and I'm going to show you how we built an intelligent assistant that can read, understand, and summarize policy documents, all with the help of Google's Gemini API, semantic embeddings, and a little engineering. Let's face it, compliance documents aren't exactly like reading. GDPR, FCA rules, internal privacy policies. They're vital, but painfully verbose. What if we could get an AI to read them for us, pick out the risks, and even suggest actions? I'm sure you have had this situation. Imagine if we could get an API to read them all for us, pick out the risks, and even suggest some actions, as I say. We then make the task as easy as asking a question, and the assistant provides a comprehensive response. This is the AI Policy Advisor, a smart assistant that uses modern AI techniques to take a user's query, retrieve relevant compliance documents, and summarize the key points with the structured output. This is the AI Policy Advisor. We will use Google Gemini's API for this demo with the following components: prompting and structured output, structured extraction of key compliance clauses using tailored prompts, document QA with RAG, where users can ask questions like, what are the GDPR implications in this policy? And this would be done with real-time document-grounded responses. We're going to be using embeddings and similarity to retrieve relevant sections from a document corpus with semantic search. We're going to be using also function calling based on findings, trigger follow-up tools, for example, to do some risk scoring and remediation steps. And finally, we're going to be using LangGraph agent to orchestrate the dialogue and manage state transitions. Before we start, let's go through a couple of things together. First of all, we need a folder with plain text policies that you may have as part of your company, for example. We're going to be using Python and Pandas. We load each document, giving us a structured corpus that our AI can work with. This will give us a data frame with file names and their corresponding text. After that, we're going to be using semantic search with embeddings. We don't want keyword search. That is a little bit old-fashioned. We're going to be using AI. In this case, we want meaning-based retrieval. That's where embeddings come in. We use a sentence transformer model to convert every document into a dense vector that captures its semantic meaning. Now, we can use cosine similarity to find the most relevant documents to any user query. After that, we can ask the assistant. The user will enter a query, our system retrieves matching documents and creates a combined prompt. This prompt is passed to the Gemini model to generate an intelligent structured response. In this case, we are using, for example, the Gemini Pro model. Finally, we wrap everything into a single pipeline. This is your AI analyst. It reads, reasons, and responds. Let's have a look at the demo. Our demo is hosted in Kaggle. As we can see, we're going to be using Gemini Power Agent to do this. Our proposed corpus could be a number of policies or privacy statements that you may have, or some regulatory guidelines. In this case, for simplicity, we're going to be using the text for the General Data Protection Regulation, or GDPR. The key components in our demo include, as we said in the introduction, prompting and structured output, document Q&A with RAG, embeddings and similarity, function calling, and LangGraph agent. Our workflow as follows. The user uploads a policy or selects from a document corpus, the system creates embeddings and indexes documents, and the user interacts via a chat interface to ask questions, ask for risks or gaps, and get suggested mitigation or steps for action. The LangGraph agent flow will go from input to retrieval, reasoning, and finally output. The outputs will include a structured summary, highlighted risk clauses, links to up-to-date guidance, and custom action plans. Let's take a look. Here we're importing our API. We're going to be using NumPy and Pandas, and using cosine similarity and a sentence transformer. Make sure that you have your API key to be able to use the system. In this case, we're going to be using the Gemini 2.0 Flash model. Here, we're simply making sure that our document is uploaded. As we mentioned earlier on, we're going to be using the text from GDPR. Here we load our documents and we make sure that we're reading all those documents with the .text file. And this will create a pandas data frame with the documents that we're using. For simplicity, we're simply using one, but you can ensure that you're reading others. The code that I'm going to show you in a moment enables us to do semantic search using sentence embeddings. This technique allows us to search for content based on meaning rather than exact words. It does this by first generating embeddings for a set of documents and then comparing a user query to those embeddings using cosine similarity in this case. Our search function is then defined to perform similarity-based document retrieval. It takes a user's query and the optional parameter top k, defaulting to 3 in this case, which defines how many of the most similar documents to return. Cosine similarity is a common metric that measures the angle between two vectors, and in this context, it quantifies how similar in meaning the query is to each document. Now we're ready to start creating some prompting functions. The first function, prompt summary, that I'm going to show you in a minute, is responsible for crafting a prompt that will be passed to the generative model. It takes a simple document text and wraps it in a structured instruction. The prompt instructs the AI model to act as a compliance assistant and to summarize the document while also identifying any potential GDPR-related risks. The second function, Gemini response, is the mechanism that actually sends the crafted response to the generative AI model and returns the result. Here are those two functions. Notice that we are asking for it to work as a compliant assistant, and we're asking them to summarize the documents and identify potential risks related to GDPR. The structure of the output should be in terms of summary, risks, and recommended actions. Finally, we will use to create a pipeline. In our pipeline, we look at the user query, provide a semantic search on those, compile the documents, and use the prompt that we have generated. And finally, we ask Gemini to give us a response. Finally, we simply execute the query. In this case, our natural language question would be, what risks are covered in the GDPR policy, for example? And this is simply what we pass to the model. As you can see, we have got a response in the terms of summary, the risks, recommended actions, as we had mentioned. This Capstone project brings together the capabilities of modern AI systems to create an intelligent, document-aware assistant tailored for compliance and policy analysis. The code showcases how to load and structure a corpus of policy documents, convert them into embeddings for semantic search, and use natural language queries to retrieve contextually relevant content. It then demonstrates how to craft structured prompts and interact with a powerful generative model, in this case Gemini, to summarize content, identify potential GDPR risks, and suggest actionable recommendations. The entire pipeline reflects an end-to-end application of Retrieval-Augmented Generation, or RAG, combining information retrieval with natural language understanding and generation. By doing so, the project encapsulates key techniques learned during the training: prompt engineering, document embedding, semantic search, and generative context synthesis. All of this orchestrated through a streamlined and modular agent workflow. This solution serves as a practical foundation for building scalable AI solutions that support legal compliance and policy professionals in navigating complex textual information efficiently and intelligently. Imagine plugging this into a compliance dashboard or a chatbot or internal search. No more Control F across 40-page PDFs and the like. I have written a number of books in data science and analytics using Python, as well as statistics and data visualization. Hit me up and let's see what you build with this. Thank you very much for watching. Goodbye.